So in this session, we are going to discuss about ports in Verilog. Okay. So let us see what are all the type of ports in Verilog and how to connect the different type of ports when we are connecting different components. Everything we are going to see in this particular session. Okay. So basically, ports in Verilog are used to interface a module with its external environment. Okay. So they allow communication between the modules and other parts of the design. So let's say this is our design. So let's say this is our design which we have design using our Verilog. Let's say it is our black box. So it is some particular design we have designed according to the specification we have been given. And so for this particular design, uh, it has some input ports. So these are our input ports, input ports, and here we have our output ports. These are our output ports, and we can also have in-out ports. So I'm drawing it as a bidirectional port. It acts as both input as well as output. This we have already discussed in our previous sessions. In-out ports. Basically, if you see, using the using the input ports, your design is getting the input stimulus from the outside environment. That is, the user is providing this input, or another design is providing the input to this particular design. Okay, to this particular design, you have an interface. So this port is nothing but an interface which is communicating with the outside environment of this particular design. It is getting input from other source or the user. Okay, so using this input ports or input interface, the design is getting the input stimulus, and using the output ports or output interface, the design is giving the data to the outside environment, or to other some module. If you have some other module, this output ports are giving some this particular data to this particular module. Okay, and using this inout ports, or you can say inout interface, the design is communicating with the outside environment. So basically, using these ports, your design is going to communicate with the outside environment or with the other design blocks. Okay, so using this particular interfaces, which is input ports, output ports, and in-out ports, you are going to communicate with the outside environment or with other design blocks. Okay, so that is what written here. So ports in Verilog are used to interface a module with its external environment, and they allow communication between the module and other parts of the design. Okay, and ports are defined as inputs, outputs, or bidirectional in-out ports. Okay, so this was about ports in Verilog. And now only we have seen there are three type of ports. One is input ports, and another is output ports, and followed by in-out ports. Input ports receive the data from the environment into the module, and output ports send the data from the module to environment. Environment is nothing but the outside this particular design. Okay, and in-out ports is nothing but serve as a bidirectional ports that can serve both receive and send the data. So up to here, is it clear regarding the input ports, output ports? Is it clear? Is there any doubt or query? Shall we move forward? So when defining a module, the list of ports is provided in the parenthesis after the module name. The list specifies the identifiers for all input, output, and in-out signals. So here we have three keywords which we are going to use. One is input, which is a keyword, and output, which is also a keyword, and followed by in-out. So these are our three keywords which we are going to use when we want to specify any type of port or the direction of a port. Okay, so let's see how to define this particular. So this is one syntax. You can declare your ports. So you can directly write your module followed by the module name followed by the ports you have: A, B, C in, sum, and C out. So these are all your ports, and you are not specifying the direction yet. Okay, so you can just simply write the port names, and after that you can mention the directions individually like this. Okay, so this is one way of declaring your ports. What you can do, you can write your module, and you can write your module name, and inside the brackets you can list what are all the ports which are present without mentioning the direction, and you can end this with the semicolon, and inside this module you can mention the direction of each and every signal like this: input A, B, C in, and output sum comma cout. So this is one style of mentioning your ports. Okay, so let's say this is your full adder module, and for this full adder module you have A, B, C in as your input ports, and sum and cout are as your output ports. So this is how you can mention your ports. This is one style of writing or mentioning your ports. Okay, and another style, if you and another style of mentioning your ports is module full underscore adder. Inside this, instead of mentioning the ports without direction, you can mention them with the direction itself. Input A, comma. So instead of mentioning just the port names, what you can do, you can mention the directions also. Input A, comma, input B, comma, input C in, comma, output sum, comma, output carry, followed by semicolon. So in this particular first style of declaration, what you're doing, you're just mentioning your port names, and after that you are mentioning the direction for this particular ports. And in second style, what you're doing, while mentioning your port names, you are giving the directions also. Okay, so these are two styles of mentioning your ports with their directions. Next, we have port declarations. So port declarations define the direction and data type of each port, and ports can be declared as wire, reg, or other data type. Okay, so let's see regarding this. And we have some port connection rules also. Let's see this port connection rules. So when connecting ports to the signals, the following rules must be applied. First rule is ports must be connected to a compatible signals in terms of width and type. This we will see in detail. And input ports can be connected to driver signals. This also we will see now. And output ports must drive a connected signal. This also we are going to see. And ports can be left floating unless explicitly allowed. Okay, so these all points we are going to see in detail now. Okay, so do remember this diagram. This is a very important diagram. Okay, so this is a port connection list you should follow when connecting your particular design with another design, or when you are connecting your design with a test bench. Okay, let us try to analyze, or let us try to understand how this particular diagram, what it is describing. Okay, so let's say this is your simple design module, which is a full adder, which has inputs coming from the external environment. Okay, that is A, B, C. Okay, so this is your external environment, or you can say your test bench or some other design, and here this A, B and C are being coming. Okay, and from this full adder you are collecting sum and carry to outside environment. Okay, so like this, you can say it as a test bench or some other design which is providing you the inputs, and which is collecting the outputs from this full adder module. Okay, now let us try to analyze step 1, which is designing your full adder. Designing full adder. Okay, so how to design a full adder? So what is the first step? Can anyone tell me what is the first step when you want to design any design? What is the first step you should do?
Declare the ports.
Declare the module first. Okay, you should write the module followed by the module name fa, and declare the ports.
Ports.
Okay, so input A, input B, comma, input C, and output sum, output carry. Okay, so these are all your input ports and output ports. Okay, so that means here in this particular module you have A, B, C, and sum and carry. So these all are your interface ports which are present for your design, which is a full adder. Okay, now from the external environment you are going to give these values. Let's say this is a underscore external, B underscore external and scene underscore external, and you're collecting it to a some external variable carry underscore external. Okay, now you are providing this, you are connecting this two pins, B underscore external, scene underscore external, and you are connecting this two pins. So is this diagram clear? So this is external environment. You can say it as a design or a user which is providing this input pins, and this also a user or an external environment or some design which is collecting this particular outputs which are being driven by the sum. So is this clear? This diagram is associated with my full adder are A, B, scene and sum and carry. So these are my input ports and these are my output ports. And signals which are associated to the outside environment, that is which are driving the input signals or input ports and which are collecting the data from the output ports are A underscore external, B underscore external and scene underscore external and sum underscore external and carry underscore external. Okay, now let's see how to connect this A underscore external to my port A and B underscore external to my port B and C underscore external to my C. Okay, so how to connect my input ports of the design, input ports of design to external environment of the design. That is, I want to connect my input port A to external environment A underscore external. Okay, and B to my B underscore external and scene to my scene underscore external. Okay, and one more thing here, my A underscore external, B underscore external and scene underscore external, so these are all my drivers which are driving my input ports. So why I am telling them as drivers? Because they are only providing my stimulus. Okay, they are only providing my inputs. So something is providing me the input, so it is called as a driver. So this is my input port to my design. A is my input port, B is my input port, C is my input port. So to this input port, you are going to get some value. So for your full adder, A, B, C, these are my inputs, so you should get some value, right? 0 0 0 0 0 1 0 1 0. Okay, so who is driving this value or who is providing you this value? A 0, B 0 and C is 0, right? Someone should provide this values, right? So what I'm saying is A underscore external, B underscore external and C underscore external are my external variables which are basically driving or which are basically providing these values to my design A, B and C. So that is what we are going to do in the test bench also. Basically in the test bench we are going to drive the values. Okay, so now I'm not focusing on the test bench, I'm speaking generally. Okay, so someone should provide you the values, right? Someone should provide the values of input ports A, B and C. It can be any value, 0 0 1 or 0 1 0, anything. Okay, so here these are providing the values or these are typically driving some values. Okay, so here this left hand side are driving some values. Okay, they are driving the input ports, A, B and C. Okay, now if you want to connect this driver to this particular input port, A underscore external to A, B underscore external to B and C underscore external to C, then what is the rules you should follow? That rules we are going to see now. Okay, so you can remember this particular design. Now what is your driver? This is your driver. The output arrow is your driver. You can say it as A underscore external or B underscore external or C underscore external. And here input side, the arrow mark represents your port A comma B comma C. Is it clear how to identify your driver and your input port? Is it clear? Don't bother about the data type, we will discuss. Just identify what is the driver here and what is the port here. You have connected. If you want to connect your external environment, external variables or your drivers to your input ports. Okay, now first answer me this particular question. Let's say here only we have written it. My first question is, what is the data type of A, B, C? What is the data type of A, comma B, comma C? Any answer for this?
Net.
Are used to drive the value. Okay, so they are not supposed to store the value. So inputs are used to continuously drive the value. So here the inputs cannot be of rich data type. They are by default of wired data type only. Sorry, net data type only. Okay, or you can say wired data type. Okay, so input should be of only net data type because it should be continuously driven by the drivers, which are the external environment, the stimulus which are getting from the external environment, which should be driven continuously. So which data type can be supported for this particular operation? What we have seen, net data type. Is it clear? So by default, this will be of only net data type. Okay. So in your when you are declaring your module, and if you want to try explicitly, if you want to give reg, okay, you can try this. You can explicitly type input reg A and try this. You will get a compilation error saying that inputs cannot be of reg data type. You will get a compilation error. So you cannot use reg data type with your input. Okay, and in this particular diagram also, if you see, where is the diagram? Yeah, this diagram. So this is your input ports, and here what is the data type they have given? What is the data type they have given? Net.
Net.
Okay, so here input side, when your input ports, for your input ports, the data type should be of net data type. And your drivers or the external pins, what can be of which data type they can be? They can be of reg or
Net.
net. Is it clear? The diagram we have seen, right? This data types, A underscore external, B underscore external, C underscore external, you should declare them, right? So this can be of reg or net. And the input ports here, A, B, C in, this can be only of net. Okay, so like this you are going to connect them. Okay, so this can be of reg or net, and this can be only of net type. Coming to output ports connection, here our output ports are sum as well as carry, and we want to connect it with our external environment, sum underscore external and carry underscore. Now let us see how to connect this output ports with our output environment, external environment. Okay, so we can connect this. And coming to the data types for this outputs, now tell me one more question. Where is this written? Okay, yeah, here we have written output sum and output carry. Now tell me, by default, what is the data type for this sum as well as carry? Whether it is reg or whether it is net. What is the data type by default? Explicitly reg, it will be of reg data type. But if we haven't declared any data type, it will be of net only. Okay, this is also very important. So if you want to store anything using your output port, you should explicitly declare it as a reg data type, or if you haven't declared anything, it will be of only net data type. Is it clear for everyone? Please be careful so when you are declaring. And here you can see the output ports, it can be of two data types. It can be of either reg or it can be of either net. Okay, so if you haven't declared explicitly as reg data type, it will be of net, and if you declared explicitly as reg, it will be of reg data type. And coming to the output external environment, this can be only of net data type. This can be only of net data type. This cannot be of reg data type, the external environment signal. This cannot be of reg data type. It can be only of net data type. And here internally, this can be of reg or this can be of net. Okay, here also it can be of reg or it can be of net. Is it clear?
Okay.
It will be by default of net. If we declare explicitly as reg, then it will be of type reg. Okay, yeah. So, and this with the help of simulation also we will see when we are by default, when we are giving that, what happens also we will see. Okay, so this was about the default connections also. And here, when you are using inout ports, the inout port, internal and external, both should be of only net data type only. Okay, the internal port also you should use with the net data type, and external also you should use of only net data type. Okay, so be careful when you are using inout ports. So internal ports, internally it should be of net only, and externally they also should be of net data type only. And please do remember this connections as well as this particular diagram, or take a screenshot anything when we are discussing about the test bench. So using this particular diagram only, we are going to build our test bench and connect our design and test bench. Okay, so that is what we are going to do with the help of this particular diagram. So up to here, the connection and the data types, is everything clear? So this was about the connection rules. And coming to width matching, so port widths must match the signal widths to which they are connected. So if the widths differ, truncation or zero padding may occur, which can lead to unexpected behavior. For example, in this particular diagram, the width of A, the internal port A is equal to 1, B is equal to 1, and C is equal to 1. Let's say the width is 1, but here externally the width is 3 bits. Okay, external width is 3 bits and internal width is only 1 bit. Okay, then what happens? Only the LSB, that is only 1 bit, will be connected to this particular ports, and remaining 2 bits will be remain unconnected. Okay, the remaining bits will be unconnected. Okay, this we will see when when we are connecting. Okay, so don't worry about that. So do remember, Verilog accepts width mismatching. Okay, I will write it here: width mismatching. Okay, so this particular thing is accepted in Verilog, but it is not accepted in VHDL. This is only accepted in Verilog. That is, the external port width, sorry, external signal width and the internal port width can be mismatched. No problem in that. This is accepted in Verilog, but it is not accepted in VHDL. You will get a compilation error saying that width mismatch. Okay, and coming to unconnected ports also, unconnected ports are the ports that are intentionally left without a signal connection. Verilog allows unconnected output ports, but input ports must always be connected. So this is also a very important point. Here we can leave the output ports to be unconnected. Suppose here we can leave this sum unconnected like this. We can remove this connection, but input ports must always be connected, whereas output ports can be left without connecting. Okay, so this is a very important point. If you want, you can note it down. So output ports can be left unconnected, but input ports must always be connected. Okay, so this is a very important. And we have illegal ports, like what is you cannot leave input ports unconnected, and illegal ports are those violate connection rules and have unsupported types, data types. Okay, like let's say, suppose for input ports you cannot use rich data type, or for inout ports you cannot use rich data type. Okay, so these are all illegal ports. Okay, so you should be careful when you are declaring your ports or port directions. So this was about the ports concept in Verilog and the connections. So that's all for this session. So in upcoming session, we are going to discuss the connections by order list and how to connect different designs, and connection by name list. And after that, we will start with the gate level modeling of Verilog. And please try to use any simulator so that you can practice with me parallelly. So